The TMS9918 from Texas Instruments and its descendants were used in many computers and game consoles of the 1980s. Because of its widespread use, it's still easy to get on eBay and only costs a few dollars. And with a resolution of 256 by 192 pixels at 15 colors, it was quite powerful for its time. See how I plugged it into a breadboard to tickle some real 80s 8-bit graphics out of it in this video. The TMS9918 and 9918A produce a 60 Hz NTSC composite signal. But there were also versions with separate luminance and color difference output, and for 50 Hz PAL too. Thus in the documentation all of these versions are referred to as Video Display Processor or VDP. The VDP holds its video data in up to 16 kilobytes of dynamic RAM. For this purpose it has its own DRAM interface. The video RAM is thus separated from the system bus, but can still be accessed via a parallel interface. The VDP is designed for use with the popular 4116 DRAMs. Each of these have a capacity of 16 kilobits, 8 of them have a capacity of 16 kilobytes. Besides the video RAM, the VDP needs a 10.738 MHz crystal with 2 load capacitors and some glue logic. We don't need this in our case, because the VDP can also be directly connected to an Arduino. And here we have this circuit on a breadboard. The VDP itself, 8 DRAM chips, and an LCD display from a rear camera serves as NTSC monitor, and an Arduino that writes the VDP registers and the DRAM over its parallel interface. The 8 DRAM chips need 3 different supply voltages. Negative and positive 5 volts and 12 volts. For this reason I built an extra power supply for these voltages. Always be careful with 230 volt. Don't use hot glue for isolation, and most importantly, don't touch it. And to my great disappointment, this did not work. All I got here on my display was complete mess. Also annoyingly, the DRAM chips died one after the other. As an aside, the chips I used here were pin-compatible clones from GDR production that were installed in Robotron computers. Since these cost about the half of the original 4116 on eBay, I thought they would be a good choice, but in fact they were not. So I was about to give up first. But then I found a clever article about how to replace those nasty DRAMs with a static RAM chip and some D flip-flops. Static RAM chips are still being made and very cheap, and they work with a single 5 volt supply. And as you can see, this circuit works like a charm. And here is the circuit diagram. The VDP is rated for a load resistance of 470 ohm, but most TVs and monitors have a resistance of 75 ohm. This makes a driver stage at its composite output necessary. Now let's find out more about the capabilities of the VDP. The chip has 4 modes, a text mode and 3 graphic modes. Text mode breaks the screen down into 6 by 8 pixel blocks. Each of these blocks holds a bit pattern that corresponds to an individual text character. The blocks consist of groups of 8 bytes each, and these 8 byte groups are called pattern. So the bits in the pattern are an exact representation of the pixels on the screen. The VDP accesses the patterns from a portion of the RAM called pattern table. Every pattern in the pattern table has a name, which is actually the location of the pattern within the pattern table. To display a pattern on the screen, we need to write the number of the pattern into one of the 768 bytes of the name table. Each byte of the name table represents one of the 40 by 24 pixel blocks on the screen. In text mode, colors can be independently set for the patterns and the background. However, all the patterns have the same color, but some combinations of text colors and background colors look terrible, also on the TV in my living room. I suppose that nowadays the manufacturer don't make any effort to display analog signals in a proper way anymore. Unfortunately, I don't have an analog TV or monitor that can do NTSC to try. Have you ever connected a home computer or game console with a TMS9918 to a modern TV? Then let me know in the comments. In Graphics Mode 1, the blocks have a size of 8 to 8 pixels. This results into 32 blocks per line and still 24 lines. Here we can assign 16 foreground and background colors for each 8 patterns in the character set. The characters 0 to 7, for example, have the same color. The same with A to H. It is difficult to assign individual colors to single characters, so this mode is not really useful. In the later A versions of the VDP, therefore, a second graphics mode was added. Graphic Mode 1 only survived for compatibility reasons and for use in systems with low memory. In the new Graphic Mode 2, the screen resolution is the same, but more complex color display is possible. In this mode we can assign different colors to the zeros and ones of the patterns. These color values are stored in a third memory area, the color table. The most significant 4 bits of an entry determines the color of the ones, the least significant 4 bits the color of the zeros. This explains the restriction that only 2 colors can occur in 8 contiguous pixels of a line. But despite these limitations, quite realistic images can be shown with the help of color dithering. For the sake of completeness, I want to mention the Multicolor Mode now. Here the screen is divided into 32 by 24 blocks with a size of 2 bytes each. So we get a resolution of 64 by 48 pixels, where every pixel can have an individual color. Due to the low resolution, multicolor graphics look very blocky, and that's why this mode was rarely used. A useful feature of many ancient video chips of the 80s were sprites. Sprites are small bitmaps that can be placed at any place on the screen. Sprites on the VDP can be 8 by 8 or 16 by 16 pixels in size. Here we see a swarm of 16 by 16 sprites. The VDP can display up to 32 sprites in 32 sprite layers. Each of these layers contains exactly one sprite and overlaps the layers with higher numbering, including the pattern plane. This might display a static background image like the flower in this case. There can only be a maximum of 4 sprites horizontally. If a 5th sprite comes in, the sprite with the highest number becomes invisible. Sprites can optionally be scaled up by a factor of 2. When doing so, it affects all sprites together. They cannot be scaled up individually. Another limitation is that only one color per sprite is possible. Despite all these limitations, the use of sprite was the only way to create animations back then. Okay, that's all about it. I don't like begging for likes, subs and money, but I also appreciate all kind of support nevertheless. Thank you for watching and see you soon.